Hi dear students, in last class we had discussed about the experimental study of a photoelectric effect and definition of a photoelectric current, factors on which photoelectric current depends, and saturation current. Okay, in today's class we are discussing about threshold frequency. It is a very important for 2 marks. Threshold frequency, threshold wavelength, and the stopping potential. Dear students, having the meaning of a frequency. Frequency nothing but f is equal to 100 by t. And what is the definition of a threshold frequency? Okay, it is the minimum frequency of the incident radiation. It is the minimum frequency of the incident radiation below which photoelectric emission do not takes place or does not takes place or not possible. That one is called as threshold frequency. Okay, already we have studied the experimental study of photoelectric effect. This one is one quartz tube attached with the quartz window attached with the evacuated tube. Here on cathode and anode plate. It is also called as emitter and collector plate. When a frequency of incident radiation falls on the UV radiation falls on the cathode plate or emitter plate, electrons are liberated. That liberated electrons we call as photoelectrons. For the liberation electron from the metal plate or cathode plate, here minimum frequency is required. Minimum frequency is required. Okay, when you apply minimum frequency to the emitter plate, at that time electrons are liberated. When electrons are liberated means current will be generated in the circuit. Okay, this is the definition of a threshold frequency. Definition. The minimum frequency is required. The minimum frequency of incident radiation minimum frequency of the incident radiation below which photoelectric emission not takes place is called threshold frequency. The minimum frequency of the incident radiation below which photoelectric emission not takes place is called as threshold frequency. Okay, its equation already know C is equal to F lambda. We know that C is equal to F lambda. Here F means frequency, or it is also denoted in terms of nu. This one is the relation between speed of light, frequency, and wavelength. When this one is converted in the form of threshold frequency, C is equal to nu naught lambda naught. nu naught, lambda naught. Here nu naught we call as threshold frequency and lambda naught we call as threshold wavelength. What is the definition of threshold frequency? Okay, it is a very important for 2 marks. The minimum frequency of the incident radiation below which photoelectric emission do not take place, but above which it takes place. That is called as threshold frequency. Okay, threshold frequency ಅಂದ್ರೆ ಏನಪ್ಪ ಅಂದ್ರ ಇದಕ್ಕೆ ಏನು ಬೇಕಾಗಿದೆ minimum frequency of incident radiation ಬೇಕು. Okay, below which it do not takes place. For example, this one is a cathode plate and this one is a anode plate. ಇಲ್ಲಿ ನನಗೆ ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಬೇಕಾಗಿದೆ. ಇದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಆಗಬೇಕಾಗಿದೆ. ಎಲ್ಲಿಂದ? ಕ್ಯಾಥೋಡ್ ಪ್ಲೇಟ್ ಇಂದ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಐ ಆಮ್ ಕನ್ಸಿಡರಿಂಗ್ 50 ಹರ್ಟ್ಜ್ ಇಸ್ ದ ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಇನ್ಸಿಡೆಂಟ್ ರೇಡಿಯೇಷನ್ 50 ಹರ್ಟ್ಜ್ ನಾವು ಯಾವಾಗ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ತೀವಿ ಕ್ಯಾಥೋಡ್ ಪ್ಲೇಟ್ ಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಮೂವ್. When you apply minimum frequency on the cathode plate, electrons are liberated. Below which, for example, 40 hertz. When you apply 40 hertz frequency on the cathode plate, electrons are does not emit from the cathode plate. When electrons are does not emit means photoelectric emission does not takes place. Okay, it means the minimum frequency of the incident radiation below which photoelectric emission does not takes place, but above which it takes place. Okay, this is the definition of a threshold of frequency. Okay, next one is the threshold wavelength. Okay, threshold of frequency already over. Next one is the threshold wavelength. What is the definition of a threshold wavelength? It is the maximum wavelength of the incident radiation. Maximum wavelength of the incident radiation above which photoelectric emission not takes place. That is called as threshold wavelength. Definition: it is the maximum wavelength of the incident radiation, maximum wavelength of the incident radiation. It is the maximum wavelength of the incident radiation above which no photoelectric emission takes place. Is called threshold wavelength. Is called threshold wavelength. Definition: the maximum wavelength of the incident radiation above which photoelectric emission do not take place, but below which it takes place. Say, this one is the cathode plate and this one is the anode plate. This one is the incident radiation. Its wavelength, for example, I am considering 50 meter. That wavelength measured in terms of meter. Okay, 50 meter it is the maximum wavelength. Okay, when you apply 50 meter wavelength of incident radiation on cathode plate, at that time electrons are liberated. I am considering only 50 meter. It is a maximum wavelength. Example, I am giving example. 50 meter wavelength of the incident radiation, it is the maximum. When it is incident on the cathode plate, electrons are liberated. When electrons are liberated from the cathode plate means photoelectric emission takes place. Below which, below the 50 meter, that radiation when it is falls on the cathode plate, at that time also photoelectric emission takes place, but above the 50 meter. For example, I am considering 55 meter. 55 meter wavelength of the incident radiation when it is incident on the cathode plate, at that time photoelectric emission do not takes place or does not takes place. That one is called as threshold wavelength. Okay, it is the maximum wavelength of the incident radiation above which no photoelectric emission takes place, but below which it takes place. It is denoted by symbol lambda naught. Lambda naught. Okay, this one also very important definition. Okay. And next one, last concept, that is the stopping potential. What is the meaning of stopping potential? Okay. See here, this one is on cathode plate and this one is an anode plate. That two plates were connected to the battery. This one is a negative terminal, this one is a positive terminal. That positive terminal of a battery, this one is a positive terminal of battery, is connected to the anode. Negative terminal of the battery is connected to the cathode. When incident UV radiation on the cathode plate, at that time electrons are liberated. Already you know the concept. Electrons are liberated. Electrons charge negative. Electrons charge negative and its anode plate charge positive. Okay. Already you know the properties of charges. Like charges repel and unlike charges are attract. Here negative charge and this one is a positive charge means it will be attract. When electron attracted by the anode plate, current will be generated in the circuit. That current is called as photoelectric current. Then when you increase potential from the battery, okay, at that time photoelectric current also increases. Potential increases, photoelectric current also increases up to one certain range. Current when reaches up to a certain range, for example, this one is the positive potential given to the positive potential given to the which plate? Anode plate. Positive potential given to the anode plate, current increases. Current will be increases. That increasing current I am considering I1, increasing current. And next one current I2, next current I3, like that. Current will be goes on continuously increasing. Well, increase the potential, current also increases. When it reaches to saturation point, this one called as saturation current. Saturation current. When it reaches the saturation current, saturation point, at that time, when we increase potential, current does not increase because it reaches a saturation point. That current we call as saturation current. Current potential increases, current also increases. Current reaches one particular saturation point. That point we call as saturation current. Okay. Now reverse the potential. Reverse the potential means this one is a negative potential and this one is a positive potential. When you apply negative potential to the anode, positive potential to the cathode, okay, at that time when intensity of UV radiation increases, photoelectric emission does not increases because it's charge, it's a potential positive. Electrons does not emit from the cathode plate. Okay, and already know this one is a negative charge plate and electrons also negative. Liberated electron charge also negative. Negative, that two are repel. Okay, anode plate does not attract the electron. When anode plate does not attract the electron means current in the circuit zero. It becomes zero. That current we call as stopping potential. That one we call as stopping potential. When current will be decreases in the circuit, it falls to zero. That one we call as stopping potential. Definition. Definition. The minimum negative potential given to the anode plate for which photoelectric current becomes zero is called stopping potential. Is called stopping potential. The minimum negative potential is given to the anode plate, or it is also called as collector plate, for which photoelectric current falls to zero or becomes to zero is called as stopping potential. It denoted by symbol V0 or Vs. Okay, this is also very important definition in the dual nature of a radiation. Okay, dear students, in today's class I am explained three very important definitions. One is the threshold frequency, and second one is the threshold wavelength, and third one is the stopping potential.